Hello students. In this video we're going to basically show you how we can use derivatives to find formulas for velocity and acceleration. So to start with, here's your first question. I want you to think about this. What is the difference between distance and displacement? So stop the video, have a think, and then restart the video once you've got an answer. So distance is always unsigned. Distance is always positive. So the distance from my home to the nearest shop, for example, is 2 kilometers, and the distance from the shop back to my home is also 2 kilometers. So distance is always positive. Displacement, on the other hand, can be positive or negative. So in other words, it's not just how far you've traveled, but it's also the direction. So the displacement of the shop from my house could be plus 2 kilometers. Then the displacement of my house from the shop is going to be minus 2 kilometers. So with displacement, it's also the direction of travel is important. So a similar question, what is the difference between speed and velocity? So once again, stop the video, get an answer in your brain, and then restart the video to see what you thought or how you went. So speed, once again, is always considered to be positive. So if I'm traveling from Rocky to Yeppoon, I'm going at 100 kilometers an hour. If I go from Yeppoon to Rocky, it's also positive 100 kilometers an hour. So speed is always positive. Direction doesn't matter. Velocity can be positive or negative. So if I'm traveling at a velocity of 100 kilometers an hour in a straight line from point A to point B, when I travel from point B back to point A, I'd be traveling at negative 100 kilometers an hour. So in other words, for velocity, the direction of travel is also important. So displacement and velocity can be either positive or negative, depending on the direction of travel. So for example, let's say we've got this function here. Displacement is represented by the letter S. So displacement is equal to time squared, where time is measured in seconds, displacement's measured in meters. So this function tells us the displacement S at a given time t. Now what if I take the derivative of that function, S dash equals 2t? Well, a derivative of a function tells us not where it is at a particular time, but it tells us how fast the displacement is changing. And the change in displacement, just like the change in distance, is speed, or in this case, velocity. So the derivative of the displacement function gives us the velocity function. So if you know the displacement, a formula for the displacement of a particle at a certain time t, find the derivative, and you've got the formula for the velocity. So I suggest you write down the formula, v equals ds dt. Now, what about acceleration? So if displacement formula is displacement equals t squared, the velocity formula is velocity equals 2t, which is the derivative of displacement. And once again, this function is just telling us the velocity v at a given time t. So if at t equals 0, the velocity is 2 times 0, which is 0. So in other words, at the start, it's not traveling at all. After 1 second, it's going 2 kilometers per hour, 2 meters per second, I should say. And after 3 seconds, it's going 2 times 3, 6 meters per second, etc. So what do we find out if we take the derivative of velocity? Well, derivative tells us the change in something. So in this case, it's telling us the change in velocity. And the change in velocity is called acceleration. So the derivative of the velocity function gives us acceleration. So I suggest you write that formula down as well. So if you know the displacement formula, you can get the velocity formula by finding the derivative. And if you know the velocity formula, you can get a formula for the acceleration by finding the derivative of velocity. So let's go ahead and do a question using all of that. So the motion of a particle is given by that function just there, where t is the time in seconds and s is the displacement in meters. So there's the formula of the expression for displacement. To get the expression for velocity, all I have to do is find the derivative. So derivative of displacement gives us velocity. So derivative of t cubed is 3t squared. Derivative of negative 6t squared is negative 12t. And derivative of 9t is positive 9. So there's the expression for velocity. And to get the expression for acceleration, we just find the derivative of velocity. So derivative of 3t squared is 6t, and derivative of minus 12t is minus 12. So that's the answer to part A. So when is the particle at rest? And they're giving us a big hint here, a big help. They're saying if it's at rest, in other words, when the velocity equals 0. So if the question was just that, when is the particle at rest? You've got to think to yourself, well, at rest means the velocity is 0. So I'm going to set my velocity formula equal to 0, which is this just here, because that's the velocity formula. I've got to solve this for t. So step number 1, I notice that 3 is a factor of each of those 3 numbers. So I can start by dividing by 3, which gives me that equation. Now possibly I can factorize this. So what are 2 numbers that multiply to give positive 3, add to give negative 4? And the answer is negative 1 and negative 3. Negative 1 times negative 3 is positive 3. Negative 1 plus negative 3 is negative 4. And that means the particle is at rest after 1 second and after 3 seconds. And part C, when is it traveling with a constant velocity? So once again, they're giving us a big hint. They're saying that means when acceleration is 0. So if you've just read the question, when's a particle traveling with a constant velocity? That means it's not accelerating, so you got to take your acceleration formula and set it equal to 0. And that gives us that. And add 12 to both sides, divide by 6. And that means after 2 seconds, at that instant, it's traveling with a constant velocity. It's not accelerating. So that's not too hard to do once you've actually learned the magic of displacement, velocity, and acceleration. So stop the video and you have a go at this question, please. Okay, let's see how you went. So the process is going to be much the same. There's the formula for displacement. So to find the expression for velocity, we just find the derivative of t squared, take 3t. To find the expression for acceleration, we take the velocity formula and find its derivative, which is just 2. Okay, the next question is interpret the expression for acceleration. So what does it mean when we say the acceleration is just 2? So stop the video, have a think, and then once you've got an answer in your brain, start the video and see if what you're thinking is the same as what I'm thinking. So in this case, the acceleration doesn't depend upon the time, so we can think of that as being just a constant acceleration of 2 meters per second squared. So if acceleration is just a number, it means the acceleration is constant. And what is the initial velocity? Once again, they're giving you a bit of a hint. When you're asked about the initial velocity, in other words, that means what's the velocity when t equals 0? So you write down your velocity equation, which is just that one, and set t equal to 0, and you end up with negative 3. So the interpretation of that is initially the particle is traveling at a velocity of negative 3 meters per second. So if you take positive being to the right and negative being to the left, it's traveling to the left at 3 meters per second at the start. Okay, and that's the end of displacement, velocity, and acceleration.